The origins of Mars and its geological features. Mars is the fourth planet from the Sun, orbiting at an average distance of about 142 million miles. It is smaller than Earth, with only about 38% of our planet's gravity, but it shares some surprising similarities with our home world. Like Earth, Mars has seasons, polar ice caps, and even evidence of ancient rivers and lakes. Scientists believe Mars formed around 4.6 billion years ago from the dust and gas left over after the formation of the Sun. The surface of Mars is rocky and barren, marked by vast plains, towering volcanoes and deep canyons. One of the most striking features is Olympus Mons, the tallest volcano in the solar system. It stands nearly 13 miles high, about 3 times the height of Mount Everest. Valles Marineris, a massive canyon system, is another jaw-dropping feature that stretches over 2,500 miles, dwarfing Earth's Grand Canyon. Mars's reddish color is due to the presence of iron oxide or rust on its surface. Over billions of years, the iron-rich soil oxidized, giving the planet its famous hue. The surface is also littered with craters, the result of impacts from asteroids and comets over the planet's long history. Atmosphere and climate. One of the biggest challenges for human exploration and settlement on Mars is its atmosphere. Unlike Earth, Mars has a very thin atmosphere, composed mostly of carbon dioxide, 95%. This thin atmosphere provides little protection from cosmic radiation and allows heat to escape quickly, making temperatures on Mars extremely cold. The average surface temperature hovers around -80 degrees Fahrenheit, with night temperatures dropping even further. Mars experiences violent dust storms that can cover the entire planet for weeks at a time, blocking sunlight and plunging temperatures even lower. These storms can be particularly dangerous for future human missions, as they would disrupt solar power generation and make visibility difficult. Water on Mars exists mostly in the form of ice, but recent discoveries have shown that liquid water might exist in small amounts, particularly in salty brines near the surface. This raises intriguing possibilities for the potential of life on Mars, as well as providing a crucial resource for future explorers. The search for life on Mars, one of the most exciting questions surrounding Mars, is whether it has ever supported life. Early in its history, Mars had a much thicker atmosphere, warmer temperatures, and liquid water on its surface, conditions that are favorable for life as we know it. There is evidence that large rivers, lakes, and possibly even oceans once flowed on Mars, leaving behind dried-up riverbeds and mineral deposits that can only form in water. NASA's rovers, such as Curiosity and Perseverance, have been scouring the Martian surface for signs of ancient life. These missions are looking for microbial life or the chemical signatures that life might have left behind. So far, no definitive proof of life has been found, but the search continues. Scientists are particularly interested in studying the deep subsurface of Mars, where water could still exist in liquid form, protected from the harsh conditions on the surface. Finding life, or even evidence that life once existed, on Mars would have profound implications for our understanding of biology, evolution, and the uniqueness of Earth. Human exploration and the race to Mars. Human exploration of Mars has long been a dream of scientists and space enthusiasts alike. Several space agencies and private companies are now racing to make this dream a reality. NASA's Artemis program aims to land humans on Mars by the late 2030s, while SpaceX, led by Elon Musk, is developing the Starship spacecraft with the goal of sending humans to Mars within this decade. The logistics of getting humans to Mars are staggering. It takes approximately 6 to 9 months to travel from Earth to Mars, and missions would need to be timed perfectly to take advantage of the closest approach between the planets. Once there, astronauts would face a host of challenges, including radiation exposure, lack of breathable air, and the psychological effects of long-term isolation in a hostile environment. One of the key hurdles is developing a sustainable life support system that would allow humans to live and work on Mars. This involves generating oxygen, producing food, and recycling water. In situ resource utilization, ISRU. The process of using Martian resources like water ice and carbon dioxide to support human life will be crucial. Terraforming Mars, a distant dream. Some scientists and visionaries like Elon Musk have proposed terraforming Mars, transforming the planet into a more Earth-like environment that could support human life long-term. The idea involves thickening Mars's atmosphere, raising the temperature and releasing oxygen into the air. However, terraforming Mars is a monumental challenge. One proposal is to release greenhouse gases like carbon dioxide into the atmosphere to trap heat and warm the planet, but Mars simply doesn't have enough CO2 to make a significant impact. Other ideas include using giant mirrors to reflect sunlight onto the poles, melting the ice caps to release water vapor, or even using nuclear explosions to heat the planet. While these ideas are intriguing, most scientists agree that terraforming Mars is centuries away, if it's even possible at all. In the meantime, any human settlement would need to rely on artificial habitats and life support systems to survive the harsh Martian environment. The future of Mars exploration. Mars may very well be the next great frontier for humanity. The race to colonize the red planet is heating up, with governments and private companies investing billions into space exploration and technology development. The first human missions to Mars will be a monumental achievement, and they will mark the beginning of a new era in space exploration. However, the challenges are immense. Radiation, lack of gravity, and psychological stresses will be major concerns for astronauts on long-duration missions. Additionally, the cost of sending humans to Mars is astronomical, with estimates reaching hundreds of billions of dollars. But for many, the potential rewards outweigh the risks. Mars offers the possibility of expanding humanity's footprint beyond Earth, ensuring the survival of our species in the event of a catastrophe on our home planet. As we look to the stars, Mars stands out as the most achievable destination for human colonization. Whether it's NASA's astronauts or SpaceX's pioneers who first step onto the Martian soil, the red planet could very well be our next home. Mars has intrigued humanity for centuries, and now, for the first time, we're on the brink of visiting and possibly even colonizing this distant world. From its towering volcanoes to its deep canyons, from its dusty plains to its frozen poles, Mars holds both mystery and promise. The challenges of living on Mars are immense, but the rewards, new scientific discoveries, the expansion of human civilization, and the potential for life are too great to ignore. As we continue to explore and push the boundaries of what's possible, Mars represents the next giant leap for humanity. It may not be easy, but the dream of setting foot on another planet is becoming more real with each passing year. The red planet beckons, and we are ready to answer the call. This video was created using AI technology to deliver the most captivating stories about space and the future of humanity. If you found this exploration of Mars fascinating, don't forget to like, share, and subscribe to our channel. Join the discussion in the comments below and tell us what excites you most about humanity's future on Mars.